All right. Technology gods be willing, we should be live right now. And it seems like it's a frantic activity on the broadcasting platform. So that's very, very nice to see. Cool. Welcome everyone to Nodes 2019. It is really exciting to be doing this. This is our first ever online conference. And we have a really, really exciting 10 or so, 9 to 10-ish hours ahead of ourselves. My name is Emil Eifrem. I'm one of the co-founders of Neo4j and the CEO of Neo4j Inc., the company. And I'm going to be sharing some opening thoughts here to kick off the Nodes conference. So warm welcome to everyone, both fellow existing graphistas as well as aspiring graphistas. A little bit before we get into the actual content, just a bit of a high-level summary of the conference. We have over 5,000 people registered in terms of, I don't know exactly how many are signed up and are listening in right now between the broadcasting platform and YouTube. But over 5,000 people registered, which is amazing. We have over 50 sessions that are going to be presented by developers in 15 countries around the world. And you see them on the little map graph here, map graphic, I should say. As I mentioned, this is our first online conference, and despite the fact that it's online, we're going to try to make it as interactive as possible. I'm going to be doing an AMA later at the end of the keynote. So if you have any questions for me, please use the Q&A tab in the broadcasting platform and ask questions. If you're tuning in via YouTube, there's unfortunately no way for you to do that, but it's very easy to sign up on that one and ask questions. There's 30 viewing parties, maybe even more, but at least 30 registered viewing parties all around the world tuning in, watching us right now as we speak. All right, cool. So I'm going to kick things off with a little bit of the state of the union, if we will, where we are in the world of graphs and graph databases. And to start off, we have this amazingly vibrant and growing community right now. And I'm going to give you a couple of examples of this. So the first one is that we launched our new community site a little over a year ago. And at this point, we have almost 5,000 of you contributing on that site, sharing your stories, helping out other developers. In that year alone, it's been over 20,000 posts on that community site, which I think is pretty astounding in just over a year. As some of you know, those of you who have been to Graph Connect or who pay attention to Neo4j and Neo4j.com, we have a startup program where we give access to our commercial enterprise edition of the product for free for startups. 6 months ago, we expanded that startup program to include free access to Neo4j Enterprise as well as Bloom, and we expanded it to people up to 50, so startups up to a size 50. And so far, we've had 50% growth in signups for that startup program this year. We're roughly at a rate of signing up 250 startups per quarter. So that's over 1,000 startups per year who are joining the startup program, which I think is very exciting. Another example of this, I guess it's 6-7 months ago now, I believe it's April 15, was the birthday of Leonhard Euler, who some of you know is if you will, the father of graph theory, the inventor of graph theory. And the community spontaneously organized over 60 events on 6 countries to celebrate the birthday of Leonhard Euler by throwing parties, doing hackathons, presentations on graph theory, and so on and so forth. Some even baked birthday cakes. So this example is a birthday cake in the shape of the 7 bridges of Königsberg, which is kind of this classic graph theory. In fact, the original graph theory problem that spurned Leonhard Euler to invent graph theory in the first place. So I guess both a tasty and intellectually stimulating cake, I would imagine. Another example, we have a weekly developer newsletter where we share an update every week on the community, on the ecosystem, and it's creatively called this week in Neo4j. And we feature developers there who have had some kind of impact on the community through the software they write, through helping out others, documentation, blogs, things like that. Every single week, we have to reject amazing content from being included in the newsletter just because there's such a sheer amount of activity with really high quality stuff. And most of this is not written by Neo4j employees, it's written by community members everywhere. We also see this reflected on the job side. So Neo4j is currently one of the fastest growing skills. There was a research report released about a month ago, maybe 2 months ago, from a site called Upwork, which is a freelance site. And when they looked at, they have, I don't know how many freelancers, but many, many freelancers, and they looked at what are the jobs, the skill sets that are in the highest demand, growing the fastest. Neo4j was amongst the 20 fastest growing skills for independent freelancers. We also see the same adoption mirrored on the commercial side. Today, over 76% of the world's biggest companies are using Neo4j, either piloting or have already adopted Neo4j, which I think is a fairly staggering number. And just to give you some more color, 7 of the 10 biggest retailers are today using Neo4j, 20 of the 25 biggest banks in the world, and so on and so forth. I'm not going to go through every industry, but 3 out of 5 airlines, 4 out of 5 telcos. It is very likely that pretty much everyone you've met this week have touched Neo4j directly or indirectly somehow. Obviously, many of the people tuned into this conference have worked with Neo4j very hands-on this week. But if you're in America and you've used an ATM, like you've used Neo4j, if you've ever booked a flight ticket, 99% of the world's airfare calculations are used Neo4j, are done with Neo4j. If you've ever stayed at a Marriott group hotel, so Marriott, Ritz-Carlton, Hilton, I guess they merged with Starwood, any of those, you've booked a hotel room through Neo4j. Massive adoption, both in small and in big companies. And taking a step back, that's Neo4j specific, because that's the data that we obviously see the best being at Neo4j. But this is part of a broader trend where the entire category of graph databases is growing very, very rapidly. There's a site called DB Engines out there, and they map out signals of popularity of databases. They look at number of tweets, they look at LinkedIn skills, job postings, Google searches, and things like that. And you see here how many different types of databases have grown in popularity over the past few years. And then you look at the growth of graph databases, and you can see that it's been the fastest growing category of databases for 3, 4, 5 years now, which I think is pretty amazing. I think part of that, one of the things, if you look back at the analogy of the relational database when it came into popularity in the 80s, there was a lot of experimentation going on, and initially they solved such a valuable problem that no matter the API, no matter the surface, in this case, because it's a database, no matter the query language, people started adopting it. After a while, adoption was held back by the lack of a unified query language for the space. We see exactly the same thing unfolding in the graph space, where we believe that over time, we are going to be held back, us as a graph database vendor, but all the other graph database suppliers, if we all go in and choose to build our own custom query language. I think as developers, we like to be independent of technology. And I think having a standardized query language is a big part of that. So we've spent a lot of time over the past few years working with other vendors to try to rally support for standardizing a graph query language. And we think that Cypher is an amazing starting point for that. And we're going to use that and a bunch of other things. And together with other graph database vendors, we're working on standardizing this into a language called GQL. If you look at that quote from the chairman of the SQL committee, it's pretty amazing when he speaks to the fact that this is the first time in the history of databases that we've seen a new type of query language emerge. In all the previous examples, the SQL committee have chosen to absorb the capabilities into SQL, right? So when XML databases, for those of you who were around back then when they came around, people were arguing that you need a separate query language for that, for example, XQuery. And what SQL did is that SQL actually absorbed some of those capabilities into SQL. And the same with object databases and so on and so forth. But they looked long and hard at the graph database market, and they said that, hey, this is different from all the other types of databases out there. This is worthy of its own query language. And they even speak about it as the query language of the database of the future, which I think is pretty amazing. Then coming back to our company, one of the things that I have to make sure that I cover in a session like this is that we are growing very fast as a company, and we are always hiring. When it comes to amazing engineers, amazing developers, we would love to get in touch. If you think what we do is interesting, is fascinating, if you love building this kind of stuff, go to neo4j.com/careers. We're biased towards where we have existing sites, which is Malmö, Sweden, where I am right now, which is London, San Mateo in California, and Munich in Germany. But if you think this is interesting stuff, please go to neo4j.com/careers and apply. Okay, switching gear a little bit, I'm going to talk about philosophy, which is even more exciting than it sounds, and specifically philosophy as applied to Neo4j and how we've thought about building products and building technologies from day one at Neo4j. So I'm going to cover some of the building blocks that have always been there when it comes to building technology at Neo4j. And the first one that I want to make sure that I highlight is quality, right? I really want Neo4j to be an amazingly performant and scalable database. But what I value above all is robustness, is reliability. When you store data in the database, it is actually there. That trumps everything else for me. And in the early days of NoSQL, it was very controversial to support transactions. This is when people only talked about eventual consistency as the only way to work with data. And we always had a contrarian view on that. We said that no, actually there's a D in ACID transactions for durability. And we want to commit, we want to guarantee that when you store data in Neo4j, it is actually there. The moment that you get response back from the database, when you say, yep, I've stored this, no matter what happens, power failure, whatnot, that data is still there. Very important foundation block for us. Similar to this is that we've always had an engineering philosophy around solving hard problems. And that may sound counterintuitive, like why would you solve hard problems? That sounds harder than solving easy problems. But really what it is that we solve hard problems so that you don't have to. Going back to that ACID example, there's other aspects of ACID that has to do with transactions, isolation, for example, and atomicity. And I've always been of the opinion that you are going to, in most applications, at least many applications, you're going to want to have concurrent read and write requests to your mutable states, to your data. And if you do that, you're going to have to be able to manage concurrent transactions and manage that potential conflict between that. And if your database doesn't do that for you, then you're going to have to do it yourself in your application. And then everyone who writes an application on top of that database that doesn't support ACID transactions will be forced to re-implement some kind of transaction management, concurrency support. Hey, if I write something over here and something over here, and they're both only valid if they're true at the same, if they're written at the same time, and one of them falls apart, right? We have a failure in between those two write transactions. That's a really hard problem. And forcing every application developer to keep track of stuff like that or face corrupt data as a consequence doesn't seem like the right approach. Having said that, writing a fully ACID compliance database kernel is really hard. But that's one of the philosophies that we've always had. We solve hard problems so you don't have to. Having said that, the flip side of that is that I think it's really important to take that power and that capability and expose that as much as possible in a simple and pragmatic surface, right? There's a bunch of other technologies that have been around for a long time around working with graph-shaped data. The property graph model always took off in a much more impressive fashion, in a much higher degree of adoption than others because of its simplicity. It's not always the theoretically smartest way to do things. In fact, frequently it isn't, but it values simplicity. The fact that you can, for example, let's take another graph model as an example, the RDF model, where you can model data on the relationships. It's entirely doable. It's just pretty verbose and it takes a while. That simplicity of being able to put properties on the relationship and just having that simple, clean model, while not the most elegant in the world always, in the end means developer productivity. And I think packaging that powerful capability off in a simple and pragmatic surface is one of the key tenets for us here at Neo4j. The fourth building block that I want to highlight bleeds a little bit into company values. At Neo4j Inc., the company, we have 6 core values, and the first one is we value relationships, and that's the relationships between us, the employees here at Neo4j. It's between us and our partners, us and our customers, us and our shareholders, like really any stakeholders. And that's really how I think about the product that we've built. We are people who value relationships. If you're people who value relationships and you build a database, you end up building a graph database because we value relationships in between human beings. We also value relationships between data points. And maybe, I'm not going to say it's the most important, but one of the most important relationships that we have is between us and the community. And one of the things that I love about how we've been able to build the product in the past is that we've been able to co-innovate together with the community. It's actually very simple to the early days of Twitter. For those of you who are Twitter active, maybe you know or maybe you don't know that the hashtag actually emerged out of the Twitter population. It was invented or coined by a gentleman by the name of Chris Messina, who just started putting hashtag in there. And for the longest time, probably for a year, maybe even 2 years, like Twitter didn't have any special support for hashtag. People just started using it. And then after a while, they watched their user base start using this, and they took that and brought it into the product. For those of you who are Neo4j users on this session, you probably know that every node has one or more labels. You can have a car node, you can have a person node, and so on and so forth. That actually didn't exist in the original property graph model. When we first sketched that out many, many years ago, we had 3 building blocks. We had nodes, we had typed relationships between them, and then we had key value pairs on both the nodes and the relationships. What we observed after a while was that we went out and we talked to users, and we talked to customers. We saw that many, if not most, had some kind of property that was called __ type, right? Or something like that, where they said, hey, this node is a car node. This node is a house node, something like that. And after a while, when we saw that enough, it comes back to that philosophy around, hey, why should everyone have to implement something very hard, transactions? We should take that on, right? We said that, hey, you know what? Wouldn't it be amazing if we offered up a facility to label nodes in a way that is a little bit more convenient, with a little bit more program surface support for it, support in the query language, and so on and so forth. And so we took that innovation that emerged in the community, and when we saw that pattern broadly applied enough, we took it and brought it back into the platform. And then the final one is self-serve first. And self-serve first is a combination of maybe company philosophy, as well as product and technology and engineering philosophy. Broadly speaking, at the end of the day, we're a B2B company, right? We build software for other businesses, right? And so we're not a consumer company. And I think at the high level, there's two ways that you can go to market when you build a company like this. And as founders, we sat back, 10, 15, many years ago, and we kind of had to make a decision. How do we want to take this to market? We've invented something that we think is pretty amazing. How are we going to get the word out there? How are we going to get the world to see and use this, right? One approach is to go high, right? Where you market, if you focus on, let's say, the enterprise market, you go in and you sell to the CIO. And you say, hey, we have this amazing product, and it's purely a slideware at that point, right? You talk about all the amazing capabilities and XYZ, right? And then if you manage to convince her, she's going to say, all right, this sounds good. I'm going to sign off on this, write a big check, and then she pushes that down into her organization, right? That's one way, top down. That's very doable. There's a lot of very, very successful companies who've built a very innovative product and become very successful with that approach. We didn't feel that that was the right approach for us. We said that, hey, you know what? The fundamental unit of value that we provide is for individual data practitioners, a single developer who's sitting there and they have a problem. The problem is that they have connected data trapped in the relational database, let's say, right? And that means that they can't do amazing recommendations. It means that they can't capture enough fraud, because of fraud rings. Or it means that there's just this big mismatch between the cognitive model for their domain and what's represented in the schema of their database, right? And that is the person that we provide value to. And what we wanted to do is have an approach where we talk about it as practitioner-led adoption, where we have the people who actually use the product day to day, adopt it, bring it into their organization, and then we go up from there. Self-serve first, practitioner-led adoption. And really, this comes back to how we got started. The three founders were all developers, and we built this, and we built it for other developers. And if you fast forward to today, over 80% of our customers actually started out as individual developers who found our open source community edition, downloaded it, played around with it, realized, hey, you know what? This is a really convenient way of looking at data. You know what? I actually have this problem, in my day job. Or this could really accelerate some of my projects. They bring it back home, or they bring it back to the office, rather, and start working on it in that way, and that's when it becomes an actual customer of ours, right? So that developer centricity is a huge part of who we are today and going forward. Now, tying back to that whole value around relationships, we value relationships. A really important thing is that co-innovation thing that I talked about before, which basically means going out there, listening to users, asking users what they're doing and what they want, but also seeing what they're doing with our software. And when I'm out there and I'm talking to users, I hear a few things right now. One of them is that you want to be empowered to build applications faster, right? It is very, very clear. Developer productivity is a huge part of the value of Neo4j, and the more we can reduce that friction, we more can make that easier, the better. The second one is scale, right? We live in this global world. We live in this world of soon infinite bandwidth everywhere, right? You can write an application that takes off and just addresses a huge part of the population. And that scalability in terms of usage, but also in terms of data accumulated, is not going to change. It's just going to get ever bigger day by day. Security is really important today, and is becoming even more important. And all the users that I talk to, or most of the users that I talk to, they want to either have the ability to be more secure, but more precisely, they want it easier to write even more secure applications. And then finally, they want to be able to launch easier, right? And so this has been a clear thing that we've been hearing over the past 4 years. And we've been working really, really hard to address all of these 4 things. And one of the things that I'm so excited about is the upcoming release of Neo4j 4.0. And for those of you who have been plugged into our community for a while, you've seen that we had 2 releases per year for a long time. Probably, I want to say 3, 4, maybe even 5 years. The years go fast now. But now, with Neo4j 4.0, we chose to actually extend the release cycle to an entire year. And we've had the biggest engineering team ever invested in graph technology working on this for almost an entire year. And here to tell you more about what they built is none other than my friend, and I want to say, Jim, employee number 7 or 8, very, very early employee out of the 300 plus people that we are today, Dr. Jim Weber. Take it away, sir.
Thanks, Emil. All. Of course, from my perspective, you are actually just a TV screen. So, forgive me if I don't get all of your feedback, but I feel particularly pleased to be able to present this part of the keynote. I've been with the Neo4j code base since around 2009, and I have to tell you that 2009 me really couldn't imagine the way that 2019 Neo4j would look. 2009 me was building a REST API, if you've ever seen such a thing, so that the database could become a server. And now I look at 2019 Neo4j, and it is an incredible leap forward. In fact, in Neo4j 4.0, which as Emil just alluded to, is the last year or so worth of our work, I feel that almost the same kind of incredible stride forward has been made in that 1 year as I've seen across the almost decade or so since I first became involved in Neo4j professionally. And it is an incredible investment. Emil says CEO level things. It's the largest investment that we've ever seen in the graph database space. Let me put that in more kind of developer friendly terms. We've invested around a century's worth of human effort in this release. That is astonishing to me. I am frankly flabbergasted. Those of you that know me, I'm not usually lost for words, but that's just an incredible feat. When I look at the amount of software that's been carefully and conscientiously developed, and it's currently wending its way to you, when I look at the amount of time we have spent harming the database and watching it recover because we value your data, it just beggars belief. I can't even believe, from a 2009 perspective, just how far things have come. So what is new in Neo4j 4.0? Well, look, literally thousands of things have happened, and I've been struggling to kind of tease apart what my favorites are. But ultimately, I think I can sort of boil them down into these 4 fundamental pillars. We have the notion of reactive database, so a database that's responsive to its clients. We have extended Neo4j into a multi-database world so that you're able to run multiple databases online with Neo4j in your cluster or server concurrently. We have a brand new piece of kit called Neo4j Fabric, which will allow us to do federated, distributed, and parallel queries over multi-databases. And because I know that everyone loves security as a developer, we actually have a really interesting and innovative schema-based security model that's coming out in 4.0. Don't tune out just yet, I promise it will be fun. But first, reactive data architectures. So in 4.0, we are taking a real big step forward in terms of making Neo4j reactive. That is, we want it to be a very responsive database, a database that's elastic, a database that's robust. Many of these things have already been in the product. Responsiveness, Neo4j is the fastest graph DB on the market. Trust me, I've benchmarked several others, and Neo4j is ridiculously quick. Neo4j is elastic. You can scale clusters up and down and so on. It's resilient. If you decide to crash instances of Neo4j, they will recover. If you crash instances in a cluster, the cluster will continue running. And I have crashed enough of these clusters myself to guarantee that they are really very, very bulletproof. But the one thing that we didn't quite have that was in the reactive manifesto was this notion of being kind of more message-oriented, more message-centric. And in Neo4j 4.0, we've done this. In fact, we have introduced a set of technology called the reactive drivers. So as a client developer of Neo4j, you now have the ability to take control over the whole stack in terms of resource usage. So a client application can fully control the flow of records which a server or cluster produces, returning to the client. So there's no longer a tsunami of records flowing back, but control flow that goes all the way through the stack, whether it's synchronous or asynchronous execution. This is based on reactive streams with a non-blocking back pressure library, and it's exposed through the reactive API in version 4.0 of the drivers. In terms of the stack, we have a bunch of new infrastructure for this. So the client uses what's called a reactive session in the driver's code base, and this is bound to a producer via the Flow API in JDK 9 onwards, or equivalent in your language. And then you can plumb that into whichever reactive framework you're most comfortable with. But what's critical is that at every part of this journey, every part of this architecture, the client can choose to pull more records through or gracefully terminate when sufficient data has reached the client. For example, the informational goal has been reached. What does this mean? It means that both on the client side, the server side, and in between on the network, the client can direct resource usage. So utilization of resources is kept to a minimum sufficient to serve the client as quickly as they can. Whereas before, very much the boot was on the server's foot, and the server would send data at a rate that it could produce, irrespective of whether the client was matched for consuming that. And that could cause difficulties. But now, much cleaner experience for a developer. In fact, in Java land, we're already nicely integrated this way into Spring Data, and in fact also therefore into Spring Boot. So if you're a Java developer, this stuff feels very natural to you. Big thanks to Gerrit, Michael, Nigel, and Jen for doing all of this work. The developer experience out of the box is just lovely. And if we compare that to demonstrate, if we just take a slight peek back in time to Neo4j 3, here's some Java code talking to a Neo4j 3 instance. This all kind of looks okay, right? So I've got a very simple query, which is to get me all the people from the database. And I start a session with the driver, and I get a statement result back. And then I'm going to iterate over that result, doing next, next, next. And every record that I get, I'm going to get a property out of it, and I'm going to look for a name. And because my boss is currently watching me from that side of the TV, I'm going to flatter him by putting his name in. And he's looking very pleased, by the way, for all you folks out there in internet land. And this all looks fine. You know, all we're doing is printing out these names until we get to Emil Eifrem, and then we're stopping, right? And if you read the code, you'd be like, yeah, this is fine. Everything's fine here. Except no. Syntactically, it looks fine. But under the covers, there is no way for this break to signal back to the server to stop producing results. In fact, the server will continue to produce results. They will continue to be flowed across the network and into the client, which can be problematic. The only way really out of this is to kill the connection to the server and then rebind, which is a bit harsh. In 4.0, the experience is way nicer. So in this case, same query, we're going to look for, not very graphy, but we're going to pull all of the people out of the database. And then using Flux in this case, we are going to create a reactive session, and we are going to pull these records from the server to the client at a rate that we can deal with. So in this case, we're limiting rate to 10. That means that we're pulling, in this case, 10 records from the network at any time. We're going to then map, and we're, again, extracting the name out of that stream. And we're going to continue to do this until we find Emil Eifrem as the name in that record. Then we're going to stop. And what we're going to do here, unlike in the previous example, is the server's also going to know to stop. So it's not going to continue executing that query and sending data back to you. It's going to gracefully stop as well. So what does that mean? It means across the whole stack, the execution of resources is governed by the rate at which the client can process, which is really neat. It means you get optimal use of resources, the client gets an optimal experience, and no longer are we storing up big buffers and sending tsunamis of data over the wire. This is a very mechanically affined model. In fact, you know, I think reactive all the things, it's a developer conference, so I get to use memes without being told off by my marketing department, which is grand. We are friendly. We're not prescriptive about which reactive framework you use. Bring your favorite one, we're pluggable, bring it along, get coding. That's so lovely. If you'd like to know more, actually, Gerrit is speaking later on today about Spring Data Reactive. so reactive in a Spring Data context. If you're a Spring or a Java person, you'll plug right into this. It's going to seem pretty at home. If you're a Java or Spring person, don't worry. It's still very accessible too, because it shows the general patterns of how you might do reactive programming against Neo4j 4.0 drivers and Neo4j 4.0 database. So do tune into that if it interests you. So working my way in through our tech stack, I think the next thing that I'm just genuinely very thrilled about is that we have moved Neo4j into a multi-database world. Now, Neo4j 3, we were able to host multiple databases per server, but only have one live database at any given time. And you may have done this by rebooting the server or using Neo4j Desktop or other scripts that you have at your disposal. It's sort of convenient, but it doesn't quite contrast with the idea of multiple live databases. In fact, in Neo4j 4.0, with multi-database, we have multiple live databases per cluster with strong isolation. So the databases are physically separate despite the fact they execute on the same cluster of servers. So a bunch of really good use cases for this. So you've got B2B software as a service. So if you're delivering software to your end users and you want to be able to keep their data separate, you now can create on a single cluster a database per customer of yours. You can implement multi-tenancy. So a single Neo4j cluster may serve multiple users within an organization. You can also do things like conveniently use the infrastructure to have your test instances versus your dev instances and so forth. You can also decide to use the aggregate throughput of this stuff to scale out. Or indeed, it's very cloud friendly, so you could choose to bring up machines, bind and rebind them to storage under the cover. So we've taken, I think, quite a great leap forward from Neo4j 3, where you could, with some effort, bring up multiple databases in a live way if you Dockerize them, or you took care to kind of remap ports and change ports in the config. But none of this really gave you a kind of unified ops experience. And as a developer, you're always kind of scrabbling around to make sure you got the right database to use. Moreover, if you tried to deal with this model in the database, so if you tried to kind of create multiple databases by convention using labels and rel types and so on, the isolation there was relatively weak. That's completely changed in 4.0. If you create a database in a cluster of Neo4j, it is physically separate from the other databases. And that's both in storage, so the files on disk, and replication. In fact, many of you will know that we have a log-oriented protocol called RAF that does dependable, reliable replication for Neo4j, and it's an individual replication instance of the replication algorithm per database. So this stuff is very, very strongly isolated. It's also very easy to administrate. Now, because all of your databases are live in the cluster, the system database understands, and is itself, by the way, replicated around the cluster, you can now get a universal view of your data. To administrate, it's super easy. It's so super easy, even a chief scientist or possibly a CEO could do it. I've just got the I'm fired symbol. So this is going to be my last presentation for Neo4j, but if you want to administrate it, you've got commands that seem humane and sensible to you. You can create drop, start, stop databases. You can address them through HTTP. You can address them through the Cypher shell. And in drivers, you can just create a session to a named database. In fact, those sessions from a driver are super lightweight. So there's nothing really to stop you from using several sessions, multiple sessions to talk to multiple databases cheaply. It just works very well. Now, this notion of a single application talking to multiple databases nicely brings me on to another piece of brand new kit in Neo4j 4.0, a piece of kit that we call Neo4j Fabric. And Neo4j Fabric provides multi-database distributed queries. Effectively, you write Cypher code, and Fabric figures out how to transmit it around the network, targets your databases, and executes them in parallel, and collects the results for you. The contract is really straightforward. You as the developer, I mean, Emil talked about this, we're trying to take the hard stuff away from you. So you as a developer, you model and store graphs in individual Neo4j databases as per your business need, just as you do today. The customer database, the marketing database, the accountancy database. I guess they're more spreadsheets, but what do? Well, Neo4j Fabric distributes and parallelizes queries and aggregations over those databases and combine the results together. It's super straightforward. So in fact, if you have many databases, you have multiple databases that support your business in this world, we've got fraud, MDM, customers, products, whatever it happens to be, you are now able to run queries across them very conveniently, very humanely. So for example, if you want to report on levels of unpaid invoices for certain products in certain geographies, and that in your business happens to span multiple databases, Neo4j Fabric can help you do that. So for example, here is a very simple example, although it comes from a real live Neo4j customer. Hi, you know you are. In this case, we are trying to get the top 10 users by photo count. So it's a photo website, photo app, and we want to know who's photographing the most. The model is trivial. I've got users that own photos, so I've got photos that belong to users. And what we're doing here is a very simple aggregation example. We've got photographs and users spread around multiple database instances depending on their geography. So I've got multi-database for geography split like that. And now this query is going to aggregate across all of those databases and give me some results. So what's happening here? Right, we're saying firstly, for all databases, so that's the unwind part, do this. And this is the call part. So it's a bit new syntax. So we're saying call. And that's allowing us to dispatch out a query to those databases. Inside that database, we're then going to find photos for users, and we're going to return them. And then the last part, the return, the aggregation stuff, is going to take all of those responses from all of those multiple country databases, and it's going to order them by photo count, by the number of photos per user, and return fork, join, or otherwise get all excitable about parallel and distributed computing. Don't get me wrong, I have a PhD in parallel computing, I'm excitable about it. But that shouldn't be your problem, right? If you need this level of hair loss, then get involved in it. If you want to maintain your good looks, this is helpful. This is zero stress, parallel distributed computing in friendly cipher query language that everyone knows and loves. It's actually really, really cute. Like, you can feel empowered by this rather than baffled. Leave the bafflement to me, I've got the face for it. One other thing I really like about Fabric is that it's non-invasive. So actually, the Neo4j clusters that you're running to support your business continue to run. They're blissfully unaware of the fact they are being having distributed queries run over them by Fabric, because the Fabric runtime sits outside of the Neo4j cluster. It is itself a fully fledged Neo4j instance, by the way, but from the point of view of your clusters, it's just another bulk client sending queries to be evaluated, collecting up the results, doing some aggregation work and passing them back to the user. So under the covers, there's a bunch of clever stuff going on, but you don't have to worry about this technology being complex to deploy or invasive to your existing line of business systems. Plug it in around the edges, and then Fabric can do the aggregation work for you. It's super, super nice. So the next thing, which, look, don't tune out. This is good. Right, security and privacy. I know that we're developers, and unless you're that particular brand of developer that can factor prime numbers in their head, security stuff's a bit hard. But actually, I think what's going on in Neo4j 4 is really interesting. Because we've had a long time to think of this and think about what security means for graphs, I think we've developed something that you're actually going to like in terms of security, which is an unusual and rather wonderful thing to say. But if we look back at what happened in Neo4j 3, I think very fondly of this release. I think of Neo4j 3 as the version in which Neo4j grew up and became enterprise strength. And particularly around the stuff we did in security. So everything was encrypted on the wire. We had users and roles. You could plug into directory services. We enabled you to blacklist properties, so certain properties couldn't be read by certain users or roles. We had Kerberos. We had security event logging. We put access controls around calling procedures. And all of the back-end stuff in Neo4j clustering was encrypted, as well as standard things like encryption at rest through Vormetric. All of this, I think, made Neo4j good enough to be enterprise ready. And in fact, we see this, right? So many of you now deploy Neo4j in your businesses because you trust it from a security point of view. And all this is goodness. But very little of this speaks to graphs, right? You could take the same set of icons and you could say, oh, well, this is a relational database. This would work for a key value store. So what is it that we've done for graphs? Well, we've taken a step back and we thought, well, you know, relational databases have things like row-level security. It's not very meaningful in graphs. What is meaningful in graphs? Well, graphs have structure and property. So we need a security system which is sympathetic to that. And so what we've come up with is a role-based access control approach, which is permission on entities for user, where we grant access for database, and then we have very granular commands around grant, deny, and revoke, targeted at any level of granularity from graph, node, rel, property, all the way through the database, cascading downwards. What I'm particularly proud about is that we've thought about graphs and we've thought about structure, and we've got facilities in our schema-based security that deal with that structure. There's a very famous paper. I've got to live up to my job title as chief scientist, so I'm going to bring up a famous scientific paper. Thackeray et al. In KDD 2015, they did an analysis, an ML analysis as it happened, on a graph structure looking for spam in a network. And without looking at any of the content of messages, only looking at the transmission graph, they were able to identify with very high confidence which messages were spam and which messages were not. What does that mean? It means that inside a graph, the structure, the relationships and nodes themselves are information even before you get down to the properties. And so our security system takes that into account. So to drive that home, we have a very simple example of data privacy. And this is it is a fictitious example, but hopefully as a learning exercise, this will make sense to you. So patient records visibility. Here's a metagraph, here's a schema. And what we have here are a patient who has a diagnosis, a doctor who's established that diagnosis. The diagnosis is for a particular disease or condition. And we see that a patient can call into a call center. And the snippet of the real graph you can see here, I've got a couple of patients who've called call center operatives. Those patients have diagnoses of diseases that have been given to them by various doctors. And I have a constraint, which is that the call center agent needs the doctor details, but isn't privileged to read the diagnosis. And if I just pop back a sec, you can see that in between patients and doctors, there are indeed diagnoses. So what do we do? Well, actually, because we've got this really lovely granular way of specifying security, we can do that. So in this case, this is some security config for Neo4j 4. We're going to create a role agent, and we're going to grant the ability to match. And match is to traverse and read on all graphs for all elements to role agent. But then we're going to deny read access on all graphs, all elements to, whoops, slight bug there, to role agent, but we're going to grant traverse on all graphs, all elements to role agents, and grant read permissions to doctor name, call center agent name. And here, traverse is the coolness. Because traverse says you can go across a relationship or visit a node, but you are not necessarily given permission to read that structure or the data therein. It's great because it prevents leakage of information through structure in the one hand, and on the other hand, it preserves correctness of queries, because you can traverse the graph in its completeness to get the correct answer without revealing or leaking data from structure or properties. If we now run this simple cipher query, so we're asking the database for call center agent Alice to which a patient has called, which has a particular diagnosis established by a doctor, we will get answers back for the patient's name and the doctor's name, but we will not be able to get any answers back for the diagnosis name. And structurally, you can see that, because effectively what our rules do is they prescribe, rather than prescribe, because that's the doctor's job, against going across the diseased relationships and the disease nodes. If you want to know more, My colleague Louise will be presenting on schema-based security later on this afternoon. Really, really fascinating stuff. I do encourage you to attend that. It'd be really excellent. As for now, the 4.0 early access release of Neo4j is already available. Get your hands on it, play with it. All this stuff is there. We love to hear your feedback. Tell us what you like. Tell us what you need to change. We're always ready to listen. And 4.0 itself is going to be released to you folks in Q1 of 2020. I hope it is just an astonishing release for you. It's been an absolute blast building it for you. So thanks for that, and I'll hand back to Emil.
Thank you, Jim. Pretty amazing stuff, I want to say. I think that Jim spoke to it. I mentioned it too. This is 3 times more than we've ever invested in a single release of Neo4j. So I can't wait to see what you all will build with it. So just to recap a little bit what we talked about. We talked about build faster, scale bigger, be more secure, and launch easier. Those were loudly and clearly what we've heard from the real world users of Neo4j out there. And we talked about, for building faster, the reactive database, or the reactive data architecture that Jim spoke to. For scaling bigger, we talked about multi-database and sharding through Neo4j Fabric. For the security stuff, that's the last piece that Jim just mentioned with a schema-based security. And then finally, launching easier, which actually wasn't really covered in the 4.0 release by Jim. And it isn't that we forgot about it, but rather, I have one more thing that I want to talk about here in terms of what we've been working on. And in fact, we've had a really, really amazing engineering team working on a particular piece of technology for several years right now. And what we know is that you all want to spend your time building amazing graph-backed applications. You don't want to spend your time managing databases. And therefore, I am so thrilled to announce Neo4j Database as a Service, which is the first fully managed native graph database in the cloud. And this has been a huge amount of effort that we've spent a lot of time on, and we've built what I think is going to be a quite extraordinary experience for all of you. So what is Neo4j Database as a Service, and more importantly, what makes it unique? Well, I want to cover a couple of different things. First of all, it is always on. So Neo4j Database as a Service is designed from the very beginning for always-on availability and for fault tolerance. I think we all know that infrastructure is imperfect, especially in a cloud world. And so therefore, we've designed Neo4j Database as a Service to have a monitoring system, an intelligent monitoring system that monitors and watches the state of the system, the health of the system, and proactively goes in and replaces faulty components. It is self-healing. And embedded in that is also that it will automatically maintain the absolute latest version of the software, the Neo4j database itself, the latest patch releases, the latest security updates, all of that without any downtime whatsoever. And I talked before about our focus and our core value of quality, and especially one of my examples was around data durability. Neo4j Database as a Service is no exception to that. In fact, we've spent a lot of time making sure that when you store data in Neo4j Database as a Service, it will be there. And so we have this layered redundancy concept where each and every piece of data that you store is replicated 3 ways across the cluster. And each cluster member, every disk is replicated into 2 data centers. There's multiple layers of redundancy for your data. If you take these things together in combination, they lead to a great design for a very robust and reliable design for always-on availability. So that's the first piece. The second one is elastic scalability. And to me, this is one of the fundamental promises of the cloud in the first place. I think we've all heard stories, and many of us have lived through stories of something like a Black Friday or a Cyber Monday, right? Where either there's a scheduled event that leads to peak load, or some unscheduled event happens and you have a bunch more traffic than you originally planned for onto your system. And kind of in the old world, in the pre-cloud world, you would talk to IT, you would send off, they would start provisioning servers, and, if you're lucky, a day later or 2 days or 5 days, more likely weeks or months later, you would have more infrastructure, right? With the cloud, the promise there is that elasticity, right? That you can scale up to meet peak loads and then scale back down. So it's been very surprising for me to see then, when you look at most, if not like many, if not most, database as a service offerings out there, while they allow you to scale up and increase capacity, they actually have to be shut down. They shut down your system, they shut down your database when they do that. And that to me seems like a very backwards way, because the last time when you want to have downtime is when that peak load is starting to hit you. With Neo4j Database as a Service, you can scale up and you can scale down with absolutely zero downtime. And thirdly, then, what this always-on availability and the elastic scalability gives you is a database foundation for building cloud-native applications. And whether that's serverless using Lambda or Google Cloud Functions, or GraphQL with a grand stack into a reactive front end, I think I'm super excited and can't wait to see all the amazing applications that you all will build with Neo4j Database as a Service. And so the question then I hope you're asking yourself is, when is this available, right? And I'm really, really happy to say that Neo4j Database as a Service is going to be publicly available in November, next month already, which I think is going to be an amazing, amazing thing for all of us to work with and play around with. But today I have a really special offer just for the people who are watching this live stream right now, which is that we're giving away early access to Neo4j Database as a Service to the first 100 developers to sign up today. And not only that, but for those first 100 developers, we're giving away $50 worth of free credit in October for your usage. So this is way ahead of launch. It's a month ahead of launch. It's for the first 100 people. Sorry for those of you who are at a launch party, because now you're going to have a scramble to find your laptop and go to neo4j.com/DBAS, Database as a Service. But please go there, sign up. Hope that you're amongst the first 100. Give it a spin. I think it's going to be an extraordinary experience. So that's that. Now I want to invite my friend and colleague, Michael Hunger. Probably, I said before, many, if not all, about Database as a Service. I think the same thing is true for Michael. I think many, most, if not all of you have interacted with Michael online. So Michael, please take it away.
Thank you. Welcome, everyone. Yeah, I'm Michael Hunger. I lead the Neo4j Labs effort within the developer relations team of Neo4j. And that's exactly what I want to talk about today. So Neo4j Labs was launched earlier this year in April as a means to incubate and provide early access to modern and new graph technologies that are really exciting for us, that we want to try out, want to give you and bring to you and make them available. And I want to talk about a few of these projects today. If you go to neo4j.com/labs, you find a number of projects that are already available under the Neo4j Labs umbrella. And I want to talk about 3 examples today. In general, the Neo4j Labs philosophy is the following. We want to make certain tools and libraries and technologies to you available early on. We want to ensure that you can use them, so we have one Neo4j employee backing all of these labs projects. And but they come, of course, with some early access restrictions. So there's, for instance, no full support for these, and we can not guaranteed that they won't be deprecated after a certain time. But anyway, so you have a number of Neo4j Labs projects here on the slide that you can also find on Neo4j Labs. And I want to talk about 3 examples today: graph algorithms, GraphQL and GrandStack, and the Kafka integration. Starting with graph algorithms, as you know, not only the transaction use cases with Neo4j are really interesting and important, but also the analytics use cases. And so I'm really happy that we have a project in Neo4j Labs that makes all these algorithms available to you. So you can run algorithms like clustering, path finding, centrality algorithms over very large databases with these algorithms. And we can extract a lot of additional value and insights from these algorithms run on your topologies. To make them even more accessible, we built an application that's called Graph Algorithms Playground that you can install in Neo4j Desktop. And that makes it really easy to get started with these algorithms, play around, see what your data looks like from the lens of a graph algorithm. And if you want to learn more, you can get a free O'Reilly book for this, written by my colleagues Emil and Mark, who have also a presentation later today. So I encourage you to check out their presentation and grab the book. And something that I'm very proud of is that Graph Algorithms was the first Neo4j Labs projects that actually graduated. So now a Neo4j product team is taking care of a core of these algorithms and makes them product ready, supported, so they will be part of the Neo4j Graph platform. The next project is GrandStack. So many of you that build modern applications with modern web technology might be already familiar with that. So if you build applications with React, oftentimes you use GraphQL as an API language to connect to your backends. And with GrandStack, we can combine all these technologies to make it even easier to build these kinds of applications. Those of you who don't know GraphQL yet, GraphQL is not a graph query language. It's an API query language that allows you to build APIs in a much easier way by making use of the fact that your application data is actually a graph. You can represent it as a type system, and then you can build type-safe APIs for these applications. So because the application data is a graph, it makes it really easy for us to integrate GraphQL with Neo4j. And so we built a number of integrations for Java, for JavaScript, and integrating the JavaScript application with React, Apollo, and Neo4j allowed us to build us the GrandStack. And for the GrandStack, we have a lot of material out there on grandstack.io. There will also be a book upcoming, and my colleague will have a talk about GrandStack all the way down today. And there are a number of other GraphQL and GrandStack talks throughout the conference. The next one is the Neo4j Kafka connector. So many of you, as users of Neo4j, have asked us about, can we integrate Neo4j with Kafka? And so we set out and built Neo4j Kafka connector as part of Neo4j Labs, which has bidirectional integration with Kafka. So you can send database changes from Neo4j to Kafka topic, but you can also ingest data from Kafka into Neo4j. And fortunately, our partner team worked together with Confluent to make this integration also available as an officially supported Neo4j integration. So we have now a verified gold Kafka connector on Confluent Hub. And this graduated basically in September, so just a month ago, into a full-fledged project and was also presented at Kafka Summit. Today you have actually 2 talks about the Kafka connector, one by a partner of ours who helped us build this technology, and another one by my colleague Mark Needham, who shows you how to build a full-stack application using GraphQL and Kafka with Neo4j. And last but not least, I want to mention that we are adding a new project to Neo4j Labs, which is Neo-Semantics, which allows you to import linked data into Neo4j and work with different kinds of linked data. And there's also a talk today from my colleague, Jesus Barraza, talking about this project. And with that, I want to give back to Emil.
Awesome. Thank you, Michael. Exciting stuff in Neo4j Labs, exciting and fast moving. So we're getting towards the end. It's not quite over. We probably have another 20 minutes or so, I would imagine, of the keynote. But you all really chimed in on the AMA, which is fantastic. So I'm going to take 5-10 minutes now and take some of, there's a lot of questions that you all have been asking, so that's great. So I unfortunately won't have time to cover all of them, or not even close to most of them. But I'm going to pick out a few and answer them ad hoc. And then after that, we have some more announcements, and then we're going to kick off the normal sessions of the conference. So the first question is very specific. It says, will anyone be talking about blockchain integration with Neo4j today? That is providing support for verifiable data in Neo4j that is verifiable against the distributed ledger. Very specific question. There's no talks in notes. I was able to just look this up. But there are other talks about graphs and Neo4j and the blockchain on the Neo4j YouTube channel. So go to the Neo4j YouTube channel. Many of you, I think, are listening in through that. And then search for blockchain, and you're going to be able to find at least some information. I don't know if it's going to answer your specific question, but at least some information about that. So next question is, how do we get involved / learn GQL, right? Great question. So I guess there's two aspects to it. One is the getting involved. The other one is learning. I think the best way to learn GQL today is to learn Cypher. So GQL, we are very hopeful that GQL is going to be completely, or at least vast majority, be backwards compatible with Cypher. Cypher represents by far the biggest user base of graph database users out there. And I think it's really important that when we're standardizing a language, that it is neutral to vendors, but that it is built out of the real world use cases, the real world experience of people actually building applications on it. So I think the best way to learn GQL today, at least practically as a user, is Cypher. So that's kind of one aspect of that question. The other aspect was, how do you get involved? And so this is a fairly open process. I don't have the URL off the top of my head, but there are published notes and minutes from all the design meetings. You can get involved, and this is much more on the query language design side of things. That's how I interpret getting involved, like contributing to moving the language forward. I'm going to have to ask you to Google that or ask on the community forum, and someone will chime in with a specific link for how to get involved. And then there's a question around migrating data from Oracle database tables directly into Neo4j. Is there ETL support or technology choices suggested for quick migration? This is something that comes up all the time, right? We believe in a polyglot persistence world, if you will. I don't think that there's going to be, like most architectures, won't use just one database in the future, not even in Neo4j. So being able to move data back and forth between these various types of databases is an important thing. Kettle is a very popular tool for ETL. We have many ETL tools that work with us, but Kettle is a great one, and I think there's at least one talk on Neo4j and Kettle by Matt Casters, the founder of Kettle, later today. So I'm going to take a few more questions here. Is there a technology stack which works particularly well for building applications backed by graph databases? I think probably the most accurate answer here is, at least if you wanna zoom out, is no. At the end of the day, we're a database. We're neutral to the stack above us, right? Having said that, I think there are application stacks out there now emerging that are better working with graph data than others, right? I'm a huge fan of the Grand stack, GraphQL, React, Apollo, and the Neo4j database, Grand, and grandstack.io. There are several talks about the Grand stack today, and it's the first time that, at least that I'm aware of, where you take a graph perspective on your data from the top, from the front end layer, all the way down into the database, which I think is really exciting. What types of applications are the best use cases for graph tech? What are some of your favorites? So I am a father of 3. This is kind of like asking which one is my favorite child. It's hard to talk about favorites. I think there's a lot of use cases that are emerging where we see a huge amount of repeatability. And what I mean by that is that if we come in and we see a recommendation project, we know that not always everything in software is particular to that situation, but almost always will a graph database be a really good fit for that problem. And recommendations is one of those use cases. Fraud detection, capturing fraud rings is one. Knowledge graphs is another, and so on and so forth. So that I think is, I'm not sure if it's my favorite ones, but I think we see a lot of success with graph databases for those particular use cases. When it comes to more particular instances, I love talking about NASA, the mission to Mars, right? Publicly on the record saying that thanks to Neo4j, which is the people at Neo4j building the product, but equally much the community participating in Neo4j who makes us all stronger and better. Thanks to all of us, humankind will get to Mars 2 years earlier. And I just think that's a quite extraordinary thing. I've lost count now. It used to be over a dozen. It's maybe even 20 now. I don't know. That we know of where people are using Neo4j to find the cure for cancer. That is hugely motivational for me, personally. So those are some examples. And then I'll take one more question before we hand off to the last announcements. This is a good one. This is a hard one, so I'll take that one last. What are useful tactics for helping people who are new to graph databases understand their value? I assume they don't mean the value of themselves, the value of graph databases. And what are the best ways to generate that aha moment? And this is a great question, one that I've spent probably most of my professional life trying to answer. We talk internally about the graph epiphany, right? I've seen that so many times when you have someone who's interested in Neo4j, they start playing around a little bit with it, and then that light switch, like that light bulb switches on, and it's like, wow, holy crap, like everything is a graph, like everything is actually connected. You maybe tend to think of the use cases as the ones where you have to use a graph database for performance, right? You physically can't, or at least it's very, very hard to use any other type of data technology. They are really valuable to us, right? But in some senses, I think the broader promise of graph databases is in the fact that it's just a natural fit for not all, but many domains. If you think of any domain, if you whiteboard the, most applications, you end up not drawing tables typically. Maybe you, as a CS person, you've been trained to serialize that, your mental model of the world, into third normal form and OR diagrams and whatnot, right? ER diagrams, actually. So maybe you've been trained to do that, right? And your muscle memory, translates that. But I actually don't think that's how most people think of it, right? And if you take most domain experts, when they draw their domain on a whiteboard, they end up drawing a graph. Hey, we have a person here who's a customer. They have a shopping cart. In fact, you can have multiple shopping carts. And in those shopping carts, we have order items. Those order items are connected to a product hierarchy, right? You wouldn't think of just an e-commerce site as a graph typically, right? But if you look at that domain, it is a graph, right? And I think getting that aha moment between the fact that your domain model in lots of situations, despite setting aside performance scalability, in lots of situations, is a graph, and that's a really good fit for the property graph model. That I think is the key, and it's that graph epiphany moment. And I think that there's multiple ways of getting there. If I knew a magical way of doing it, like I would be using it all the time. I've observed that visualization is a huge part of that. Some of you may have heard of our Neo4j Bloom product for you doing graph visualization. It's a very, very popular piece of technology. And it's very powerful in conveying the value of graphs, getting people to understand that, wait, this data, my own data is actually connected. So that seems to be a big part of it in terms of in terms of visualization. But then I think that you all on this call, you can fill a huge role here. Just talk to people about what, if you're using Neo4j, talk to people about what you're using it for. Tell your friends, right? And because many times the applications for graph databases are much broader than the preconceived notions. So I think that's probably one other way to address that same topic. Thanks, everyone. This was easily 2-3% or something like that of the questions. I really appreciate that you took the time to ask them. If you didn't get in, like for the 97% or so who didn't get an answer, please go to our community site, community.neo4j.com, sign up there if you're not already there, post one of the 20,000 per year posts so that someone like me, others at Neo4j, or other community members can chime in. Speaking of community, now I want to hand off to my friend and colleague Karin, who's going to talk a lot more about what is in store for the community and what's been going on in the community site for a while. Karin?
Hi, thanks, Emil. Hi, everyone. Thanks for watching. So I wanted to talk to you guys a little bit about what happened with Global Graph Hack. So if you've been following along, we had launched a 4-week virtual hackathon. After the project submission deadline, 3 winning projects would be selected through a voting process, through a combination of community votes and a panel of judges made up of Neo4j employees. And the winners of the Global Graph Hack would win the opportunity to present their projects in DevZone at Graph Connect 2020 in New York City. That also includes their flights, hotel. They also have an exclusive invite to the private Neo4j Ecosystem Summit at Graph Connect 2020 and the opportunity to connect with some of the Neo4j executive team. So when we were thinking about what we want as the theme for Global Graph Hack, we decided on something that can actually give back to the community, because that's what community is all about, is supporting one another. So we ended up with a theme of extending the graph ecosystem. So the task was to build something that helps others in the community. So it can be tools, extensions, integrations, something that helps the Neo4j ecosystem as a whole. And participants could, create any kind of project that they're interested in, as long as it does something to help the other folks in the community. So, went ahead. So the winners for the Global Graph Hack there's 3, and they are as follows. Meetup Mixer by Sarah Staub, Aaron Schuberth, Nathan Smith, and Steve Petrie. This team is made up of 4 data and math enthusiasts from Kansas City. Using GrandStack, they developed an application that the goal was 2 things. One was as an icebreaker for people who are attending meetups, and the other was to help people who are interested in learning Cypher and Neo4j. So the application was designed to collect data about people's interests and then match them up with other people at a meetup based on their common interests. And then also, people who are using the application have the ability to go right in, make adjustments to the Cypher code, and they're learning Cypher that way. And they can adjust Neo4j directly. So that is our first winner. We love meetups, we love community, people who give back, and this is a combination of a little bit of a lot of things. So that's our first winner. Our second winner is Neo4j JMeter Load Testing by Luann Mesquita, Aldrin Mesquita, and Nicholas Mervey. This project stemmed from a personal pain point. This team was doing high volume imports into Neo4j, and they found themselves creating a lot of custom procedures to be able to connect and do like performance testing. So they created a Bolt protocol support to connector with JMeter alongside some of the folks from the JMeter team, and they made the ability to do Bolt load testing very quickly, like matter of 5 minutes for other users. And they also have some examples inside the application that they created. So if you want to test it out, you're more than welcome to. And our next winner is NeoMap by Estelle Sifo. We love spatial visualization. Estelle built a Neo4j desktop application that allows you to connect directly to an active graph inside Neo4j and visualize nodes with geographic attributes on a map. And you have the ability to do it through location and heat maps. And Estelle hinted to us that there is more to come, so we're super excited to see what's next. One thing I do want to mention is that we did have a lot of really amazing submissions. And even though we had, I think I went ahead. I don't know how to, I lost my slide. I don't know which slide I'm on. Okay. I don't know what slide I'm on. So even though we went, we had these 3 hackathon projects that were selected. I do want to make a point to say we had some incredible submissions. We went through, I think there were like 17 really solid submissions of all kinds of projects. I highly suggest if you have the opportunity to do so, you should definitely go check out the projects. You also have the opportunity to go to the community site and chat with the creators of the projects directly. There was some really, really incredible stuff. When I was looking through it, I was really in awe. I do want to add also, there's a lot of ways to contribute to the community. You can blog about a side project that you're working on. You can go speak at a conference. You can answer questions on the community site for people who need technical help. Even if you're reading something that you find interesting that other people in the community have written or created, let them know, because that is also active community contribution. So I wanted to point that out. There's a lot of ways to get involved. You can join our community site and start there. You can go to the Introduce Yourself channel and introduce yourself. Mention Nodes 2019 in your topic, and we'll be sure to connect on how we can get you involved. And the last thing before I go and set you guys off on a wonderful day is if you are interested in playing today, we are going to have the Hunger Games going on. The Hunger Games are modeled after our very amazing Director of Developer Relations, Michael Hunger. So after every presentation, there's going to be 3 questions presented to you, and you'll be able to answer those questions. Your time limit is how long the Q&A is, and the winners with the highest amount of correct answers by the end of Nodes 2019 win a $50 gift card to Graph Gear Store. So you can get yourself some nice Neo4j swag. And that's it. So let's get the show on the road.
Thank you, Karin. What an amazing example of just how fantastic this community is. I mean, it's if you look at those winners, super interesting projects, right? And they were just one out of, like, they were obviously the winners, but there's several more who probably could have won as well as those 3. And so I really urge you to go and check them out. Quite extraordinary. Cool. Thank you so much to everyone. I really want to thank you for paying attention. This, again, is the first time we're doing this. It is not as easy to pay attention to 90 minutes worth of content when you're alone in front of your computer or even at a viewing party as when you're physically face-to-face at an event. And so I want to really thank all of you for participating. The normal sessions are going to kick off at the top of the hour. So I'm going to challenge my ability to calculate time zones on the fly. So that's 4 p.m. Central European time. And so that would mean 10 a.m. Eastern time in the US. And then please calculate whatever local time zone you're in with those 2 as anchors. But it's in half an hour. Thanks again, everyone, for paying attention. Have a fantastic day and a really great online conference. Thank you, everyone. Stay connected.